While working on your application, you might run into an exception, which can be frustrating at first, but an exception usually means that the application can't run any further and it crashes. Luckily for us, we can find and handle those exceptions while developing the application. This way, we can make sure the application doesn't crash, but it shows the user a nice error and let the user fix it. But in some cases, the user can't help it, and we just notify the user this is it, and the application will stop. And the user should contact support. In this video, I want to show you what exception handling in C# is and how we apply it. So before I'm going to dive into the code, I want to tell you a bit about exceptions. An exception in C# is an error or unexpected situation that occurs while your code is running, also known as you are running the application. When an exception is thrown, it means that something has gone wrong and the code cannot continue executing as you would expect. If you don't do anything, the application will stop working and it crashes, showing a message a user wouldn't understand or doesn't need to see. This is something we want to avoid at all costs. We need to handle those exceptions so the user gets a nice message and maybe log the errors for the developer to see what went wrong. And this is what we call exception handling in C#, handling the exception. Exceptions are thrown, which describes the act of sending or throwing an error to another part of the code. When your application throws an exception, it signals that something has gone terribly wrong. The flow of the execution is disrupted and it needs to be handled if the flow wants to continue. To continue the flow, you need to catch the exception and handle it accordingly. You can write the code so the application can recover from the error and continue. If the exception isn't caught, the application will crash or do something you don't want it to do. With exception handling in C#, you catch the thrown exceptions, examine them, and act accordingly, or you ignore the exception and let the application crash. An exception is a type, but there are many types of exceptions. When exception handling in C#, you need to know there are different types of exceptions, but it is impossible to learn them all. There are exceptions for files, like file not found, file already exists, directory not found, etc. Also for variables, value cannot be null, incorrect value, etc. and many more. Most exceptions will be thrown by C# and .NET, so it's good to know you need to read the exceptions and sometimes look them up on the internet. But you can also throw exceptions on your own when needed. You can do this when you are doing validations, for example. Alright, enough theory, let's dive into the exceptions. So I'll be using a very simple console application and I will be using .NET 8 and C# 12. Alright, so say I have a very simple console application like this. And for the mathematicians here, do you see what could go wrong here? Knowing what could go wrong in your code is the first step of exception handling in C#. But it's not always possible since you could be using third-party components or sources, or like a database or user input. So let's run the application and enter the values 6 and 2. Alright, so the first number is 6, second one is 2, and the result is 3, which is correct because 6 divided by 2 equals 3. And it's exactly what I'm doing here. Alright, so now let's restart the application and use the first number 6 again, but now let's divide it by 0. And this will result in an exception. It is impossible to divide a number by 0, so you get an exception. The code has no idea how to solve this, so it throws an exception and it ends the application. Now let's look at the exception itself. The first thing I notice is that it says exception unhandled, which is correct because I'm not handling it. If the exception was handled, it wouldn't show this message. The second part is system.divided by 0 exception. This is the exception type, and it already gives us a hint about what is wrong here. Some exceptions come with an extra message like this one. Attempted to divide by 0. Okay, it does say the same as type, but still it is a message. And then you have some extra options like as Copilot, show stack trace, view details, copy details, start live sharing. I'm not going into details on these because it's just too much information. I'll stick to the basic exception handling. Now if we continue the application, the console will look like this. It doesn't look really user-friendly because it says the same as what we just saw in Visual Studio. We don't want our application to crash, and instead of letting this happen, we should handle the exception and show the user a friendly message. Exception handling in C# is pretty easy. We need to use the try-catch. The try-catch consists of two blocks. One block that executes the code and one block that catches the exception. This is the first step of exception handling in C# and let's add the try-catch. So in this case, the error can occur here because this is pretty self-explanatory. So I will start by try. Now our code is tried, and when something is wrong, it will reach us the catch. And the catch has a parameter exception x. So as soon as something is going wrong on this line, the code in the catch block will be executed, and I will be writing console.write line something went wrong x.message. All right. So I've isolated the first number divided by second number. This way, if something happens and causes an exception, it is caught by the catch. In short, if the application reaches an exception inside the try, the catch will catch it. The catch has a parameter, exception x. Exception is the base of all exceptions. Earlier we got it divided by 0 exception, and if you look it up and look at the inheritance, you will eventually find the exception class. So it doesn't matter which exception is thrown, the exception will always be hit in this case. So for example, you can, let's change this to divided by 0 exception. When I press F12, I go into the class and then it inherited from this one. I can go in that one, system exception, and when I go in that one, I will see exception. So you have to do a few steps inside all the types of the exceptions, but you will find the base class exception. You can look into the exception, and well, this is actually where it starts, and you can see a few properties and methods. And I have been using the message. All right, let's put this back to exception. The exception, as I said, has a few properties and methods. One of them is message, which is the message an exception could throw. Other well-known properties and methods are the stack trace and source. An exception could also have an exception, which is called an inner exception. The inner exception is used to give more information about the first exceptions, but it's not always there. Usually it's null. All right, let's run this piece of code. 6 and 2. Okay, that's still 3. Let's run it again. Now 6, 0. Something went wrong with a typo. Attempting to divide by 0. So this is the message I have written because of the typo, and this is the message from the exception. And you can see the code doesn't break anymore, it doesn't crash, it just gives a nice, understandable message, and then it can continue, or in this case, it ended in the normal way. So this is a very basic example of exception handling in C#. The application still stops, but it doesn't crash. It also gives a message to the user what went wrong. In this case, the user could try again to avoid the problem. While the previous example works and it shows how you could do it, there is a better way. Yes, you could check if the input of the user is correct and act on it instead of throwing exceptions, but this is a video about exceptions. What I'm pointing at is the catch exception X. We now know that all exception types are derived from the type exception. So this catch block does work. But it doesn't give us any clue about what it's from, especially when the exception doesn't give a message. In some cases, something went wrong. With exception handling in C#, it's better to handle the known exception types rather than the global exception type. This way you know what exception is thrown, and maybe you can even fix it instead of showing a message to the user. So let's continue on this example and try to figure out the divided by 0 exception. We do get a divided by 0 exception when we try to divide something by 0. This we know. We can add another catch, especially for this exception type, and be more clear to the user. So to add another one, we can simply catch divided by 0, like I did a little bit earlier. All right, this isn't wrong, but it does give error. And if you look at it, a previous catch class already catches an exception of this or a super type exception. Exception is a super type because divided by 0 exception is derived by exception. So this means that whatever exception is thrown in the try, it will always be handled by the exception, and it will never reach the divided by zero exception, because exceptions are handled from top to bottom. And in older versions, this might work, and you will never get the code to execute in divided by zero exception. What you need to do is turn them around. So in this case, when the divided by zero exception is thrown, you will come in this catch clause. When another exception is thrown, you will reach the exception clause. And let's put a message here. So because we now know it's divided by zero exception, we know this exception is thrown as soon as the second number is zero. So we don't have to check the message or show the message. We can write our own message. Now we can add more types to the catch clauses, but at some point you need to stop. It has no point in writing 20 different catches, only use those that are relevant and that need to be handled. I would still keep the catch with the exception type. If something else is going wrong, you still get a nice error for the user and you know where to start looking. Do remember that the code after the try catch will still be executed. So, for example, let's add another console.write line here. Or better yet, let's place this here. And then result equals or is all right. What I have done is create a new variable outside the try catch, and that means that I can use it outside the try catch, and like here. So, and I made it nullable. Result is first number divided by second number, and then at the end it will say the result is the first number divided by second number equals result. All right, so let's run it. Let's say 6 is the first number, second is 3, and then 6 divided by 3 is 2. Awesome. And let's try again. 6 divided by 0. You can't divide 6 by 0. The result is 6 divided by 0 is nothing. It does give a strange result. So do keep in mind when you are exception handling in C# that the code after the try catch is still executed. And if you use variables that are handled inside the try, it could lead to strange results. So far we have been handling exceptions we didn't know were coming. But sometimes you know a certain piece of code will throw an exception, or you need to make sure the user knows the code will crash if nothing is being done about it. In such cases, you can throw exception on your own. We usually do this when validating data in the back end of the application. When a value from a user is incorrect, you can throw an exception and the front end will handle it. And the front end will make sure the user gets a nice message or the opportunity to fix it, if possible. So I have changed the code a little bit. I've created a class which has a simple method divide, which will divide the first number and the second number, and it returns the result, which is just an integer. Now, my program.cs, I have changed it because I added a method, the main, and it will do the same thing as we have done before. It will ask the first number, the second number, and then initiate the calculations class, and then call.divide, first number, second number, and then put the result in the variable result, and then write it to the console. Now we haven't applied an exception handling in C#, so we need to add it. But I want to keep the divided by zero exception from happening. Let's assume that the calculations class is in a C# library somewhere, and it's used by other applications as well. It has no point in handling the divided by zero exception, since each application might handle it differently. Instead, I want to check if the second number in the divide method is not 0. So I will add the following validation. If second number equals 0, throw new argument exception, second number can't be 0. I throw a different exception, the argument exception, which indicates that an argument of the method is incorrect. I can handle this exception in the front-end application. So after this calculations initiation, I will add the try, catch. I know an argument exception will be thrown, so I will be adding this. And the exception just in case. All right. I will place these two lines inside the try, because if this one fails, it has no point in executing this line of code. And console.clear, I want to clear everything from the screen. Console.writeLine, argument exception message, console.writeLine, just an empty line, and then execute the main again. All right. So because we know the argument exception is because the second number isn't correct, we can just put the message, because we have written the message ourselves in here, and then execute the main again so the user can try it again, because it's not an exception that should make the application crash. Now, when something else is thrown, something different than an argument exception, then it will execute the last catch, the exception clause, and we cannot do anything about it. And then throw. I will be coming back to that later. So when I run this, now first number 6, 0, second number can't be 0. That's the exception we have got and handled, and the user can try it again. And now it ends in a normal way. So if there is some different exception thrown, the exception catch will hit. It will write down that it can't be handled, and it rethrows the exception. The user still gets a nice message, but the debugger will also be hit. Another reason to rethrow the exception is to get the stack trace. When you handle an exception, you might lose the path it has taken to get to the exception. The downside of rethrowing is that the user gets a nice message, but also the exception as shown, so use it wisely. It is good to apply exception handling in C#, but it's even better to debug them. If you don't know why an exception is thrown, it's more reason to debug it. So I have a little bit of code, and this will write some text to a file which is located in my_files file.txt, and it writes the text through the file stream and a stream writer. Nothing special, I'm not going into details about this, but this will throw an exception. When I run the application, it will throw an exception, system.io.directory_not_found exception. And let's assume we have no idea why and how. Of course, we could start by reading the message, but that's too easy. If you have a huge project, the message could not give a good idea of where the error occurs. Instead, click on Show Call Stack. This will open the call stack window and show you the output of where the exception occurs. And the exception was thrown in the program.main string arguments line 4, which is where the file stream is created. Now, this is all cool and all, but we need to handle this exception. I have to change the code from the console application so the error is not occurred anymore. So I will be starting by creating a method, and I put everything inside that method except for one thing. I will stop the application. I will be putting a try catch here, and starting with the exception is not a good idea. I will be start by directory not found exception, and of course add the exception anyway, because you never know. All right, and I will just rethrow it. So the debugger will show that something is wrong. I'm not going to give a message to the user or let the application crash. Instead, I'm going to directory.create directory path, and then execute the start again and call the start from the beginning. All right. So I've added try catch and handled the directory not found exception. If this occurs, I create the directory and I will try again. When a different kind of exception is thrown, the exception catch is executed. So if I put a breakpoint here and run the application, you will see that the directory not found exception is hit, and it will create the directory and then call start again. And now the application is finished. If I run the application and keep the breakpoint is not hit, the exception is not thrown. So we have fixed the exception. Of course, what I would rather do is add an if statement here, check if the directory exists. If not, then directory.create and then move on. But this is to show you how you can handle exceptions and not about how you can validate your data. A file stream and stream writer have to be closed after they are opened. In our example, the streams are opened but never closed, only when the application stops. If the application is opened and the writer gives an error, the file stream is not closed. If this were an active API, this would cause a lot of errors if the file was in use in other locations of the application or by different requests. To fix this, we can implement the finally. We can use this class of the try-catch to close the streams if they were loaded. One of the biggest advantages of the finally is that the code block inside the class is always executed, exception or not. So let's add the finally. The finally is always added at the end of the try-catch, and we can't access the file stream here because it's inside the try, which is a different scope because the finally is inside the scope of the method. So we have to move the streams multiple to the top. We make them null. And then initiate them in the try. And now we have file stream. If nil, let's close. Writer, if nil, dot close. That's it. So if an exception is hit, and let me show you. I will put a breakpoint here and here. Let's run the application. Okay, so the first exception is hit, the directory not found exception, because I removed the my files directory. And when I press F5, it goes into the finally, while the stream is not nil. So that's cool. And when I run it again, the directory not found exception isn't thrown. There's no other exception. So the finally will still be called, even though the try is successfully. All right, last thing I want to talk about is the exception filtering. In some cases, the same exception type is thrown for different reasons. These reasons are usually hidden in the message of the exception. You don't want an enormous if statement in your catch class. What you do want to do is use exception filtering. So let's say we have this piece of code. We see an if statement inside the catch class. Although this isn't wrong, it does make it look bulky and it's harder to maintain. Instead of using the if statement, let's implement exception filtering. And exception filtering is checking the message before entering the catch clause. And to do this, you use the when keyword. And the when is, like it says, only enter this catch clause when something is true. In this case, x.message can't divide by 0. And now we can copy paste this and just change the when. So this is one of the decision making in C#, and that's exception filtering. Using exception filtering makes your code less bulky and easier to control. So exception handling is a vital part of your job as a developer. Exceptions are here to tell us something is really wrong and it should be handled. Users don't have to see, or actually don't want to see, the exceptions since the messages are hard to understand and even scary sometimes. Instead, we should handle the exceptions and give the users a nice, friendly message and tell them the application is crashed in a more sensitive way. Although I do use exceptions a lot, handling and throwing them, I do think most of the work can be done by using if statements. If statements are a bit more friendly and easier to control, and exceptions do take more memory from the device and could cause other problems. Do know how to use a try-catch with or without the finally, and how to handle the different types of exceptions. And this was it for the exception handling. I do hope you enjoyed this video. Don't forget to like this video and follow my channel for more videos. More are coming soon. Thank you for watching, and if you have any questions, please let me know in the comments. Hope to see you in the next video.